Hi guys, so here's video 2 for lesson 7.2, isosceles and equilateral triangles. We left off on this slide, and what I did is I brought in the pieces in pink that go into that table. So going through this proof, the statement, I'll restart. Statement 1, angle ABC is congruent to angle ACB because it's given, all right? Angle B being congruent to angle C is given. Those are just other ways of writing those angles. Number 2, segment BC is congruent to segment CB because of the reflexive property of congruence. Number 3, angle ACB is congruent to angle ABC because of the symmetric property of equality. They're symmetric. Number 4, triangle ABC is congruent to triangle ACB because of angle, side, angle, triangle congruence theorem. And then for 5, segment AB is congruent to segment AC. That's what we're trying to prove. Okay, so that completes the proof of the converse of the isosceles triangle theorem. Proving the equilateral triangle theorem and its converse. So an equilateral triangle is a triangle with 3 congruent sides. All 3 sides are the same length. An an equiangular triangle is a triangle with 3 congruent angles. Okay, so here's our theorem, which is another main idea, an equilateral triangle theorem. If a triangle is equilateral, then it is also equiangular. Okay, so if all 3 sides are the same length, then all 3 angles are the same length is what that says. So we're going to prove that, and we're going to prove its converse. So the other way around. Right here, I'm going to be dragging these pink words into the places they go. So prove the equilateral triangle theorem and its converse. Step 1, complete the proof of the equilateral triangle theorem. Given side AB is congruent to side AC is congruent to side BC, and that's what's shown in this picture. These little tick marks on all 3 sides of our triangle show they are all congruent. That's given. We're going to prove that all 3 angle measures are also congruent. Measure of angle A, angle B, and angle C. So given that the measure of angle AB is congruent to the measure of AC, we know that the measure of angle B is congruent to the measure of angle C. And that's because of the isosceles triangle theorem. It is also known that the measure of angle A and the measure of angle B by the isosceles triangle theorem, those are congruent, since the measure of AC is congruent to the measure of BC. Therefore, the measure of A is congruent to the measure of C by substitution. Finally, the measure of angle A is congruent to measure angle B, which is congruent to the measure of angle C by the transitive property of congruence. So the converse of the equilateral triangle is also true. So this is another main idea, the converse of the equilateral triangle theorem. If a triangle is equiangular, then it is equilateral. So if all 3 angles are the same, then all 3 side lengths are the same. Okay, so we're going to complete the proof of the converse. So we are given that all 3 angle measures are the same measure, and that's what's shown in this picture over here. The little angles are represented as being all 3 equal. And we're going to prove that the length of AB is congruent to the length of AC, which is congruent to the length of BC. Okay, they're all going to be the same size and relativity to each other. So because angle B is congruent to angle C, That means side AB is congruent to side AC. And that's because of the converse of the isosceles triangle theorem. Side AC is congruent to side BC by the converse of the isosceles triangle theorem because the measure of A is congruent to the measure of B. Thus, by the transitive property of congruence, angle AB being congruent, side length AB being congruent to side length BC, and therefore, we've now proven our theorem. The side length of AB is congruent to the side length of AC, which is congruent to the side length of BC. All three sides are congruent. And that completes your notes.